a sustainable and efficient change in energy, development in Germany, but even abroad. So who are we? Next slide, please. Just some key facts about our company. We are a leading provider of direct methanol and hydrogen fuel cells for stationary and mobile hybrid power solutions. So you can see we were founded in the year 2000, 20 years of experience in the fuel cell market with over 50,000 fuel cells sold worldwide. This is more than any other fuel cell manufacturer has in the market, and so it gave us a higher level of experience in that field because we've been in that market a long time ago. Next slide, please. Thank you. So what are our markets? You can see here we have the market clean energy and mobility, which focuses mainly on industry and civil customer applications, defense and security. We're one of the few fuel cell manufacturers who produce fuel cells for military and security organizations, and also the oil and gas market, which seems a little bit strange, but even here you need off-grid energy to monitor, for example, large pipelines in Canada, Alaska, and so on. What are typical applications for industry? You have mobile towers, for example. You have cells on wheels, backup power for IT data centers, for hospitals, for telecommunication, railroad and transportation control units, transformer stations, and so on. And in the defense and security markets, we focus on mobile, vehicle-based, and also portable power supply solutions for the demanding applications of military users, government organizations, and also private security providers. We have developed here a comprehensive product portfolio for the demanding requirements of military users and law enforcement authorities. I will tell you more about it in a few minutes here. You can see the power ranges we're focusing on. So you see up to 1.5 kilowatt. We use our scalable direct methanol fuel cells, and for any higher power demand, up to 50 kilowatts, we use hydrogen fuel cells. So next slide, please. I will just do this quick because Mr. van der Ohe already told you how the system works. So when you have the fuel on the one side from a fuel cartridge or a hydrogen storing unit, or even from an electrolyser. But how does the fuel cell with the battery work? When connected to a rechargeable battery, the fuel cell will constantly monitor the battery charge state. And once the battery capacity drops below the desired capacity, the fuel cell will automatically start recharging the battery. Once the battery is completely charged, the fuel cell will automatically revert to standby mode. The fuel can be stored or produced on-site with scalable electrolysers, which were presented by the colleague from Enapter. So please, next slide. This is, I will only talk about this shortly, the comparison of fuel cells with diesel generators. If you compare these two technologies, you will soon realize that diesel generators require regular maintenance and regular fuel supply, resulting in high logistic costs through transportation and maintenance. Furthermore, Diesel generators have high emissions, CO2, NOx, VOC, and noise emissions, and it also diesel also gels at sub-zero temperatures. Many more disadvantages here, but inappropriate fuel supply or engine maintenance creates also a security issue, and there's of course a high risk of theft and diesel and the equipment. So compared to conventional generators, the fuel cells from SFC offer numerous additional advantages that meet the most stringent requirements. At the same time, fuel cells are quieter in operation and produce less waste heat, and the lower noise emission and thermal signature are clear advantages for all users in the field. Apart from that, the fuel cell does not emit environmentally harmful emissions such as nitrogen oxides or carbon monoxide, and they supply power to all terminal equipment reliably in an environmentally friendly manner. So next slide, please. Here on this side, you can truly see one of the main benefits of the fuel cell combined with a battery. The example you see here is for 100 ampere-hour battery, and you can clearly see the demand-driven versus conventional power supply, where the diesel generator produces more and more fuel as higher as the power demand goes. You see down the actual power which is required, and you see the power line, the battery with the fuel cell follows the demand-driven power demand. This is one of the key reasons why this technology is so cost efficient, because you have very, very low consumption. And combined with a battery, you can target all the relevant aspects like acquisition and operating costs, comfort, logistical effort, and peak load, which are provided by the battery. And the fuel cell provides base load protection, security, continuity, efficiency, and low operating costs. Next slide, please. This is one of the applications which is very, very proven in the field. Onboard power supply via fuel cells. You have the advantages here that you have a fully automatic, efficient battery recharging unit without starting the engine. You have autonomy in every situation without using the engine or generator, which saves you primary fuel. You have a reduction of fuel consumption, of course. You have a reduction of energy maintenance and vehicle batteries cost. It is non-detectable, it is emission-free, and has also a low noise operation, which makes it perfectly for the use for security organizations and the military. And it is also used by numerous armies and law enforcement agencies across the globe. Therefore, this technology offers enormous energy benefits here, which are used mainly by government customers. Next slide, please. Just to give you a brief overview what we can provide with fuel cells and with battery charging, with battery units who are able or which are able to store a high amount of energy in the tactical view. It is a perfect power supply if you think of refugee camps, hard to reach areas after disasters, because it's an easy to use, reliable power supply, crisis communications, for emergency applications, for major incidents, or for mobile solutions, for complex and even robust operations. It is a game changer for military and security organizations, because the partial substitution of diesel generators here makes it very much possible to combine the respective specific advantages of power generation. Next slide, please. I'm sorry, I think presentation, yes, thank you. Thank you. This brings me to another reference case we have in India. It is a reference case by the Indian Army, where our fuel cells, our direct methanol fuel cells to be precise, are used for border surveillance. There are 200 fuel cells in the field, up to 6,000 meters, and the cost and diesel and the costs you are saving here are enormous, which I can show you on the next slide. Before our fuel cells were introduced, you have had a very complex transport of fuel and diesel with over 9,000 liters per year, which make a cost amount of around 84,000 euros. With the MLE fuel cells in use now, you have around 400 liters of methanol per year, and with a cost of around 3,700 euros. Next slide, please. Here I just wanted to show you some references or applications for civil, semi-stationary and stationary applications, like construction sites, events, relay stations, mobile communication hubs, demonstrations, even wildlife observation, and so on and so on. You can see here various solutions we provide for speed measurement of water levels, railroad signaling systems, construction site monitorings, and so on and so on. And the example I wanted to show you here is that you can use for 43 days of energy autonomy. You can use around 2 M28 methanol cartridges, which contains 28 liters each, with a fuel cell of us who provides around 125 watts. So the nominal power consumption here is not more than 30 to 200 watts. Next slide, please. I wanted to show you one of the biggest application possibilities we have here, which is backup power supply and grid hardening with fuel cells. Just to give you a few application examples here, we provide very much backup power systems for the BOS digital radio network sites in Germany, for range extender systems, for emergency power battery systems of transformer stations, or even emergency signal converter for local authorities. All these systems are hydrogen based and have a power range from 100 watt to 20 kilowatt, and have a standalone operation for, I think, up to 120 hours. The references here are, for example, the Deutsche Bahn, Hamburg port and power grid, and of course the BOS radio. But I wanted to show you, some other examples on the slides to come. So next slide, please. This is an installation example of the BOS BTS radio towers in Germany. Many of these systems are in use in Brandenburg, in Bavaria, Baden-Württemberg, and even in Hessen. The requirement here is to provide 5 kilowatts for 25 hours. And the solution here are 2 hydrogen fuel cells with 10 hydrogen cylinders in an outdoor cabinet. Next slide, please. Here we have an installation example for a backup power supply for an IT center. There, one hydrogen fuel cell is used in a container solution, and you see the hydrogen cylinders are stored separately, but this is an outdoor container solution, so it's matching, or it's perfectly able to combine these two. Next slide, please. This is another interesting example I wanted to show you. This is an application we have for the German Bahn, for the German railroad company, and we provide emergency power supply for signal boxes with our hydrogen fuel cells there in 2 variants, one up to 6 kilowatts, the other one up to 20 kilowatts. And you can see this is also an outdoor application. Which brings me to the next slide, where we have an indoor application. So even this is possible, where we provide backup power supply and continuous power supply for a transformer station of an IT center. There, the indoor cabinet is used, so the fuel cells are stored inside, but the hydrogen is stored outside on the building with enough security and safety measures, so that there's no danger that something bad might happen. Next slide, please. This is a very interesting example for telecommunication towers. We provided that for the telecommunication company E+, and you can see this is a perfect example for improving energy availability for the infrastructure of mobile communications, even in India, by ensuring continuous power. India is the second largest telecom market in the world, and the power supply in India, is that 70% of the diesel generators, radio masts, are affected by approximately 8 hours of power outage per day. So approximately 2.5 billion liters of diesel are consumed annually in India in mobile communications and for the towers. And this makes an approximately amount of $732 million annually. Just imagine that what a low consumption and cost-efficient hydrogen solution here would do to the costs that are now in place. Just an interesting fact here: India's largest telecom company, Infratel, is already operating around 16,000 diesel-free sites last year. So I just wanted to give you a brief overlook over our methanol cartridges, which brings me to the next slide. Thank you. As you can see, we have distribution partners all across the globe. Our headquarters is here in Germany. We're a German company. But our fuel cartridges regarding hydrogen are now available in numerous countries worldwide. They are easy to handle. They are stored in impact-resistant plastic containers, and the user never comes in direct contact with methanol. They are also approved for air transport in accordance with various regulations by the German Ministry of Transport. So next slide, please. This is actually an example I wanted to share with you because these are power grids which are actually in use in India. As I mentioned before, our solutions are integrated in robust solutions to operate even under the most extreme conditions. And in addition, our products here offer the flexibility to include solar energy. And in this combination, the solar model will provide power as long as the sun shines. And in bad weather or winter conditions, when there's not enough sunlight, the fuel cell will automatically fill the power gap. SFC Energy here has successfully completed the delivery and installation of an order of fuel cells. Those are 500-watt fuel cells for remote sites in across 4 northeastern Indian states. And as part of the order, these fuel systems were installed through our partner we already have in India. The company is called FC Technology, and each system consists of 2 EFOY Pro 12,000. This is the fuel cell you see right at the bottom, through our partner, and with a total output of 1,000 watts. A solar panel of around 5,000 watts, and with a lithium-ion battery bank, an intelligent energy management module that provides through a hybrid 230-volt AC inverter. Such applications for remote areas and off-grid sites like the northeastern corner of India are tailor-made for exploring the fuel cell technology to its full potential, and we see a very bright future for fuel cells in India, which are hydrogen-based, even in microgrids. Which brings me to the next slide. Which is the conclusion, in fact. So I will just summarize it up very brief and shortly. The advantages at a glance are that you have a significantly weight reduction and reduced particle emissions. You have high autonomy and a smaller footprint by considerably reduced maintenance and operating costs. You have a silent operation compared to conventional generators, and an easy to operate without extensive training, because it's a very safe, simple, and fast integration process. And for many users, are they, for example, like portable, stationary, and even mobile. This and the very low fuel consumption of SFC fuel cells are significant. Because I think the question will come how much fuel is consumed here. The fuel cells require less than 1 liter per hour fuel per hour. This simplifies the logistics and significantly reduces the need to stockpile fuel compared to diesel generators. This is the end of my presentation. On the next slide, you find some selected customers and sales service partners we have across the globe, even in Asia and India. And I would like to share a short video with you, which hopefully answers all your remaining questions. So thank you, and back to you, Mr. Winter.
Yeah, thank you very much. Let's play the short video.
Durch den Einsatz der E-Fuel-Brennstoffzellen werden unsere Baustellenüberwachungstürme über einen langen Zeitraum netzfern und ohne Benutzereingriff mit Strom versorgt. Das spart uns Personal- und Logistikkosten.
Here at Fuel Cell Systems, we're using the eFoy Pro fuel cell to charge the auxiliary batteries for the control systems in the mobile hydrogen refueling unit. The eFoy Pro is environmentally friendly and it runs quietly, and that's perfect for our application.
Wir von der GW Umwelttechnik setzen die eFoy Pro nun seit ungefähr einem Jahrzehnt in den Stromversorgung unserer GWU-Leader-Trailer ein. Sie ergänzt dabei unsere solare Stromversorgung, wenn diese bei schlechten Wetterverhältnissen nicht mehr ausreicht.
Jedes Projekt hat spezifische Anforderungen und wir von SFC Energy AG bieten die perfekt abgestimmte und individuelle Energielösung für unsere Kunden.
Our fuel cell solutions from SFC Energy enable the modern soldier today to fulfill their missions more efficiently. In the recent years, we found out that the modern soldiers got burdened with a lot more different systems, like radios, night vision devices, thermal devices, and many more. And all of them need energy. How is this currently solved? This backpack shows an example of a current setup with a simulated radio and its respective standard batteries. And as you can see, those take a lot of volume in the backpack and surely a lot of weight. How do we solve this? With our fuel cell solutions, we can reduce weight and volume taken by our systems and the batteries a lot. In an average, we can reach up to 80% weight reduction. Now I'm going to show you the Jenny 600S, which actually represents the smallest direct methanol fuel cell on the market worldwide, which is TRL9, off-the-shelf ready and mill standard tested. The Jenny produces 25 watts, weighs 1.7 kilograms or 3.7 pounds. How does that actually work? Well, the Jenny produces the energy from our liquid energy source, the methanol, which is safe in handling for the end user, through a chemical process inside. And the Jenny itself is hot swap capable, which means you can change the cartridges while the Jenny is running. This setup here shows an example how many end users already use it. When I connect the Jenny to the energy network with our Power Manager 3G, the Power Manager 3G with its 6 ports automatically starts to harvest energy from the Jenny and distribute it to the different systems. This way you have an energy network which enables you to connect multiple devices simultaneously, which works automatically and is highly reliable. All of our defense products are designed, developed and manufactured here in our headquarters so they are made in Germany. I just showed you the Jenny 600, the Power Manager 3G in conjunction with our energy network. But we also have defense products with higher power capabilities like the Jenny 1200 and the MLE 3000. SFC energy defense products represent a highly reliable plug-and-play solution, reducing the soldier's weight.